rock samples of the bottom to identify the type of the crust, which is required by the commission, a CLCS, or which will give us the recommendation on our extended continental shelf. And JAMSTEC, they brought two vessels, research vessel Kayo and deep sea research vessel Kyray. Kayo is a SWAT vessel, and Kyray is a seismic vessel, and of 3,400 tons and 45,000 tons. And this is one of the OBSs they used. There are 4 different players, as I mentioned, and here is cabinet, and there is interministerial meeting, and there are many ministries involved, and all these ministries are coordinated by cabinet secretariat to make the data gathering and analysis and drafting of the submission document. And the result is the total track line for geophysical survey was 610,000 nautical miles with full swath bathymetry and 290,000 nautical miles of reflection seismic. And out of that, 22,000 nautical miles are of multi-channel seismic. And as for the OBS survey, 20,000 nautical miles of refraction survey was made with the 6-kilometer interval of OBS deployment, and in total 66,000 deployments was made. And the multi-channel seismic was made over the same line. The recovery of the OBS was quite nice, of 99%. And using the BMS, 470 core samples obtained, in total 2,300 meters. And other than that, 40 dredged samples was made. The reason we used core samplers was because the surface of the sea bottom of most of the areas were covered by calcium carbonate or the manganese nodule. It is really hard for us to dredge the real rock because the sea bottom is covered by resources. Total ship time was 7,845 days, and the total manpower was 321,000 persons day. And I tell you the budget side was 54 billion yens, and it could be translated like 500 million US dollars, but because of the drop of the value of the US dollars, I don't want to mention in terms of US dollars, and also the euro. Here is Ogasawara Island and Ogasawara area. This is a place where people thought it will not be possible to extend the continental shelf because here is the plate boundary. How one can extend its extended continental shelf over plate boundary? We made a very detailed survey here. I show you the result of the survey. It's a flyby. Your camera will fly from here to here and check the continuation of the bathymetry. We are flying from the north to the south. And now coming to the Ogasawara Island. This is Ogasawara Trench, and this is Mariana Trench. And this is the place in question. Feel like motion sickness. That's a beautiful girl. It's not the lack of the data, it's really densely surveyed. The sea bottom is about 5,000 meters, and the top is 1,300 meters. As you see, the area is filled by the material from the Pacific Plate side. And the stress skin of the tectonic stress is seen. If you have the cross section of this area, it's like this. And the place where one may think the plate boundary is located here, and this is shallower than this place. And the deep ocean floor is something like this. So the plate boundary is much shallower than the deep ocean floor. Whereas in this place, the depth of the trench exceeds 9,700 meters. The deepest point is located here, and the deepest point is 9,781 meters. This is the cross-section of the same area using multi-channel seismic. The enlarged map of this area is here, and the multi-channel seismic line is here, and I paste the same record profile here, like this. And what I want to show you is that the eastern side goes up to the western side to make the western area. That is, the western islands are made of the eastern side of the plate boundary. It's already accreted completely. One of the examples is this calcium carbonate, which is the summit, seen on the summit of the Guyot of this area. But you can see the same thing on the western side of the plate boundary, like this. And this is the cover page of the Japanese submission. And we are claiming to extend extending the continental shelf in this area, the 7 areas. Now I tell you the relation between our extension of the continental shelf and the mineral resources. The mineral resources are identified during the continental shelf surveys and other scientific surveys. For example, polymetallic sulfide and ferromanganese nodules and cobalt-rich crust are found in many places. Methane hydrate. This is not a result of the continental shelf, but methane hydrate have been found and really abundant around Japanese area. And natural gas and petroleum and the bioresources like these things. I have a scientist, a friend scientist, who is working on deep ocean creatures, and he said he tried to eat this thing, but he stopped the idea because the food of these clams are bad because they are methane and sulfide. Do you want to eat something like who eat methane or sulfide? And they live at the depth of 3,000, 4,000 meters. Once you recover that, they are dead because of the pressure. And in a couple of days, they are sent to the laboratory. When the clams arrive in his laboratory, it's already corroded, rotten, and the originally it smells like sulfur or methane, and so it's nothing you want to start eating. Okay, I have only 3 minutes. Okay. The resources, I tell you, the resources. This is the oldest part of the seafloor in the world, of the 160 million years or older than that. And you can find manganese nodules and cobalt-rich crust here. And these are the new eruption area, newly erupted areas. I show you the textbook of the sea bottom, the plate subduction, and here comes the eruption. And this area you can find the polymetallic sulfide. You see, the sea bottom around Japan is the same as the textbook. And also, we have the Okinawa Trough, which is the it's a pre-rifting stage, and you can find the vent, active vents. But very interestingly, oops, it disappeared. Sorry about this. This manganese nodule was seen, it's a big one, which I have in my office, is found here at the depth of 1,600 meters. It's not deep at all. And it's on the ridge system. The challenges are two E's: environmental concern, and we are doing just starting the monitoring and scientific research and assessment. Another E is evaluation of the mass of the resources, which is using AUV, BMS, and ocean bottom gravimeter. And AUV, which comes with the side-scan sonar, multi-beam echo sounder, sub-bottom profilers, and sub-bottom profiler with high frequency to measure the thickness of the cobalt-rich crust. And also, it comes with some of them comes with the chemical sniffer to smell. And we are planning to do the dense boring using BMS of the every 50 meter or 100 meters to measure the assess the amount of the polymetallic sulfide, and also ocean bottom gravimeter observation of the dense distribution. Okay, I conclude my talk with the movies of the sea bottoms. I skipped this one. This one comes with the nice views of the gyros. And this is the oldest, one of the oldest portion of the globe of the 160 million years. You see beautiful gyros, and the summit depth is 1,300 meters. The vertical exaggeration of this map is 1 to 10. So 10 times exaggeration. Sea bottom is really flat, except some areas with the bulge. This particular seamount we are looking at is the width or diameter is about 100 kilometers. The relative height is about 5,000 meters. And this is Nankai Trough, which is not related to mineral resources, but the area we enjoy. We will enjoy, sorry, the thank you. Methane hydrate at this area. Our plate is moving this direction, and the sediment is accreted to this place and makes the methane hydrate. Thanks to the full coverage multi-beam bathymetry, we can enjoy this thing. And for example, there is a cut, a valley, which the different portion of the earthquake generation system. And also you can see the sea bottom river, which is the river from Mount Fuji. This is Mount Fuji. And you may know the ukiyo-e thing, like this, like this. Okay, this conclude. We are looking at this place. This concludes my talk, and I'll finally show you how I took the picture of the globe. The globe is like this. If you go to Urayasu, which is the next town of Tokyo, there is Tokyo Disney Sea, and in front of the station, you enjoy this one. And the globe is rotating the right side. They know which way to turn the globe. Okay, thank you very much.